Hi everybody and welcome back to Miss Angler's biology class. I am Miss Angler. In today's video, we are going to be looking at a history of microscopes. Included in this video, we are also going to be looking at the different kinds of microscopes you get, the types of images, and how to interpret what you are seeing when you use these microscopes. Now, we're also going to look at how to correctly use a microscope and how to identify the different parts as well. But if you are new here, don't forget to give this video a thumbs up and make sure you're subscribed because I post new videos every Tuesday and Thursday for grades 8 to 12 life sciences. So let's get into the video. Starting off the history of microscopes, depending on what your school and what your teacher wants from you, they may require more or less information than I'm going to provide now about the history of the microscope. So depending on what your teacher has asked you to learn, just keep that in mind. You may need to know the names of the people and the years, but I'm going to make it really simple and start off with the first compound microscope, which was this guy over here, all the way back in 1595. Now, the most important part about the history of microscopes is actually the evolution of glass, which really surprises a lot of people. But if you think about it, microscopes are able to do their job because they have lenses in them. And we're going to talk about lenses soon as well. And lenses are made out of glass. Now, how well you make that piece of glass, so how smooth and how even you make it, will determine the clarity of the image that you make. So glass played a really important role in creating a microscope. Then we move on to a very famous name that some of us might know. It's called Leeuwenhoek microscope of the 1600s. Now, he was also accredited with finding the more accurate or perhaps the more intricate type of microscope, but the one that we actually want to focus on the most is Hooke's microscope of 1970. Now, Hooke is also accredited with something else, and he's accredited with the cell and giving it that name and being able to see cells for the first time. The most important thing about the history of microscopes is, remember, before we had a microscope, we didn't know anything was microscopic, right? So that means we didn't know about bacteria and viruses or cells for that matter. So people before these times had ideas and thoughts that may not necessarily have been true. Only after the invention of these microscopes could we actually see what is visible to the naked eye. But then you'll notice that for quite a very long time, we didn't really have a strong microscope up until 1884, where we actually had what looks like a more modern microscope, something that might look more familiar to us. If we move on to the actual modern microscope, this might look similar to the one you have in your classroom. It might be a more simple version of this, but this is what we use today. We use electricity to create the image with our light source. These older ones actually use the reflection of the sunlight, which is actually what this little thing is down here. It's a little mirror, and it captures the sun and then reflects it into the microscope itself. Now, the final thing, the most interesting thing, is we have developed even further in microscopes, and we have created an electron microscope. Now, electron microscopes do not use light. All the other microscopes you see here use light except for electron microscopes. They use electrons to create the image, and they can see the smallest of the smallest things because they use electrons, which are already very small, to create the image that we see. So before we move into microscopes and what their structure is and how we use them, it's really important to have a very basic understanding of how light is used to create an image and how light is really important in a microscope. So when we are actually looking through a microscope, we are looking through a piece of glass that is enhancing what we are seeing. And so let's just talk a little bit about light, and we need to know some of the basics about light and this lens. So in front of you here in the red, we have lines of light. Now I want you to know, number one, light travels in a straight line, as we can see. However, when light has to move through something like glass or water, it bends. And as you can see through this piece of glass over here, this lens, it doesn't remain straight, it actually bends. So what happens is when we put a lens anywhere, in a microscope or in your glasses, what happens is the light enters through that lens and it is refracted, which means bent, and it's bent towards a central point, which is what you can see. All of these lines of light are all bending towards what we call a focal point. Now, a focal point is an intense image, very, very clear image that we are creating. But you'll notice you need a much smaller area to see it, right? Because what it's doing is it is collecting light from this really large surface area over here, and it's collecting it down to this very small point, which means that what you're able to do is you are able to see something, if you think about it the other way, something that's very small, you can also make it really big. Okay, so think about this lens just pointing the other way. We can make this really, really big, and lenses help us do that by magnifying things. And you might have seen this with a magnifying glass with newspaper print and how I can make it a lot bigger. Now let's go into the first kind of microscope that we will get, the most common that we get in school, which is called a light microscope. And as the name suggests, it uses light, just like we saw now with the diagram before, to make an image bigger with the help of a lens. Now, depending on what grade you're in, and if you are in grade 10 watching this video, and potentially grade 8s, you will need to have to label a microscope and give functions of certain things. So let's run through the main labels that we see here. First of all, we have the eyepiece at the top. This is the bit that you look through. So you're going to look down this tube. Then we have the arm, which just holds up all of the lenses in the eyepiece. We have the nose piece, which refers to this bit over here. And the nose piece actually rotates. Why does it rotate? Because there are what we call objective lenses. And those are these 3 lenses that sit at the bottom here. Each one of them will actually have a different magnification. And generally, they are going to be 4 times bigger, 10 times bigger, and 40 times bigger. We do get different numbers, but those are the 3 main magnifications that we get in the objective lenses. We then have the stage, and the stage is this area over here where we would put the specimen, the slide. We have the diaphragm, which is this bit at the bottom here that allows more or less light through the image. And then you have something called the coarse adjustment and the fine adjustment knob. And so this is the bigger one, is the coarse, and the fine is this smaller one. And the differences between the two is the coarse adjustment moves the stage up and down, so closer and further away. And so that gives you the more coarse image. It's not as clear. You can make it super, super clear if you use the fine adjustment. The next is the light source. Now this particular one, this light source is a light bulb, so you'll need electricity for this one. And last but not least, the base, which is what it sits on, and that's also what we use to carry it. We're going to hold the microscope by this part. Now, when we are calculating magnification, which again I'm going to explain in more detail in the next video, calculating magnification, when we look through a light microscope, we actually look through 2 sets of lenses. There is a lens in the eyepiece, and then there is the objective lens. The eyepiece is generally always 10 times. Now, the objective lens changes. As I mentioned in the beginning here, you could have any one of these 3. So actually, when you are looking through a sample, and let's say I'm looking through the objective lens 4, right? You are actually looking at 4 times the 10 in the eyepiece, which means you're looking at 40 times larger. And the same for if it was the 40. If I have 40 times 10 of the eyepiece, it would give me 400 times closer or bigger. And so you can actually calculate the magnification when you're actually doing these activities in class. Now, just to show you what a light microscope looks like, light microscopes do not have the ability to get all and every detail. So often they give us like good cell pictures. And so this first one is a very common one that we always see. That is actually just some simple epidermal cells, some onion cells to be specific. It's probably something you would be able to see in school, and you can see you can't see very much detail, right? You can potentially see the cell wall, maybe the cell membrane, the cytoplasm. If you're lucky, you'll see a little nucleus here or there. But besides that, you can't see too much detail in this one. I'm going to show you a slightly more complex picture, which we might be able to see with a stronger microscope, maybe not one that we have at school, but what you're looking at here is a cross section through a stem of a plant. Now, each one of those little circles is a cell, and you can see they have different sizes. They seem to be different colors because they've been stained. And what you can see here is how the cells are arranged within one another. But do you still notice that they're not very detailed? We can't really see what's inside the cells. They seem to be all clear or empty. And the stronger the light microscope, the more detail we can see. But if we want to get really close, we're going to need a more powerful microscope. Which brings me to the electron microscope. Now, if you've ever seen a light microscope before, you will now notice that this microscope, the electron microscope, is massive compared to it. If we were to draw it in for scale, a normal light microscope would actually sit about this tall. And so an electron microscope is really large. And there are a lot of differences between the two, including how we make the image and also what the image looks like. But also, when we do have an electron microscope, you can look through the eyepiece over here if you really want to, but most people actually just look at the computer screen, which is where the image is actually formed. Another thing about these is that generally we don't have these in school settings. These are more in university, and you'll see now why, because they're a little bit more complicated and they require a lot more skill to use. Now, electron microscopes come in two kinds, a transmission electron and a scanning electron microscope. We're going to start off with a transmission. Now, the word transmission actually gives us a clue as to how we make the image. Now, again, depending on the grade that you are in and also maybe your school, you might need to know this in more or less detail. I'm simply going to cover the basics so you know how it works. Now, a transmission electron or a TEM microscope basically uses electrons. Now, if you've forgotten electrons, I just want to refresh your memory. But in every single atom, you have a nucleus in the middle, and then moving around it is the electron. So this is the electron on the outside. And so those are the little things, small little atomic particles or subatomic particles that we are going to use. And what we do is we shoot them with an electron gun, which I know sounds very exciting. But actually, you've actually seen an electron gun before, or you've seen one in use, because we actually find them in televisions. We use electron guns to create the images that we see on TV, actually. So it works very, very similarly, but you'll notice there are some major differences, and we are looking inside the electron microscope now, so you can't actually see the outside parts. But basically what happens is the electron gun is like shooting electrons. I want you to imagine these little energized particles, and they are moving through various structures like an anode, a condenser lens, and when they hit the specimen, which is what we have here, you will notice if you follow all the lines, they all come together into this very intense point. And that's important because the specimen we are looking at, we want to look at the smallest things in cells. So we want the electrons to help us do that by creating an image. And they do that by making a shadow, which is really cool. And they make this shadow that we can then see. We see the shadow that they leave behind. If they can't move through the structure, then that area will be black. If they can move through the structure, then it will be like white or shades of gray. Then you will notice that the light the electrons dissipate and they move out. But at the back here, you will see there is a fluorescent screen. And that is where we capture the shadow I was talking about. Now, I think what's best is to show you what does the image actually look like. So this is an example of what a transmission electron microscope image is and what it looks like. You'll see it's in black and white. Sometimes they're in color, but that's because they've had color added to them afterwards. And what you are actually looking at here, if you're not so certain, is we have zoomed in here very, very close to a chloroplast. This is a chloroplast. Okay, this whole thing, let's do the outline. That's the edge of the chloroplast. And what you are looking at here is the thylakoids. So if you know what that is, it's these little stacks over here. And that is where photosynthesis takes place. These darker lines over here are going to be probably starch granules. And what you're looking at here is the shadow that is left behind, where the transmission electron has shot the electrons through the specimen, and if they can make it through all the way, then they have like a white to grayish appearance. If they can't make it through, then it's a darker black appearance, and that's what we get here. But you'll notice this is a 2D image, and so that's something that we need to keep in mind, is that transmission microscopes make 2D images. Now, moving on to the sister of the transmission electron is the scanning electron microscope, or the SEM. Now, the scanning electron microscope, as it suggests, scans, which means it actually shows the outside. So a good way to tell the difference between the two is the scanning shows the outside and the transmission can show the inside. And you can see that the inside of the electron microscope is slightly different on this one. We still have an electron gun shooting the electrons out. It's moving through an anode, and you can see here are all the electrons being moved through, and they go through a magnetic lens. But then on the other side, you see the stage and the specimen is actually on top of each other. It's in a different location, isn't it? And so let's say we were looking at this ant or this insect. And basically what's happening is the electrons are moving through the device and they bounce off the specimen. And when they bounce off the specimen, they don't necessarily show you the shadow. They are showing you the, let's call it the reflection of the specimen. Is it like a light reflection? No, it's not like a light reflection, but it's a similar thing that I can compare it to. But to help you understand what I mean, let me show you what an electron microscope image looks like. So this is pollen under a scanning electron microscope, and you can see the beautiful detail of what pollen looks like. And each one of those is a slightly different pollen, and so that's why they have different shapes and sizes. But you can only see the outside, right? You can't see what is in the inside. If we wanted to see the inside, we would use a transmission electron microscope. So let me actually show you what that looks like side. This is just a quick example to show you that we have pollen, as we saw in the other diagram on the previous slide, and that is going to be on the scanning. So this is the scanning one versus the transmission one. And as you can see, they make very different images. Remember that the scanning one is showing us what is on the outside, and the transmission one is showing us what is on the inside. So if we took one of these pollen grains and we wanted to see what was on the inside, now we can. We can still see some of these structures though. For example, these spikes on the outside of this pollen grain, they are these structures over here that we can see sticking out. But what we can see now, which is really interesting, is we can see the nucleus, right? We can see little maybe vacuoles, the nucleolus, we can see it all put together. And so those are things that you can't see with the scanning electron microscope. You'll need a transmission electron microscope. Now, one last thing I want to point out to you is this little guy over here. This is a scale bar, and it tells us by how much has this thing been magnified depending on the scale. Now, when we count in microscopes, or when we use microscopes to show how big something is, centimeters, meters, millimeters, it's not small enough. So we need two different measurements. What we need is micrometers, which we write like this. That is a micrometer, which is smaller than a millimeter. And then even smaller than a micrometer is a nanometer. And a nanometer is the smallest unit of measurement that we use when we use microscopes. And so what this little line over here means is from here to here, that is 10 micrometers. So roughly this pollen grain is about 20 micrometers. It's double the size of that scale line. But if you're interested in how to actually calculate that, and maybe you've gotten to the point where you need to show how to show calculations of magnification and that kind of thing, then you should watch the video that follows this one. Now, as always, I like to wrap up my lessons with a terminology recap, and I do this so that you can use these words for flashcards, for studying, and so to check and make sure that you know exactly what everything is that we've learned. So we looked at light microscopes, and I spoke about reflecting of light and how light can reflect off a substance or a thing that you're looking at. And that's how light microscopes will work. They will reflect light off of it and then into your eye. And we also looked at the structures within a light microscope. There was something like an eyepiece, stage, the coarse adjustment, and fine adjustment. But again, you might have to learn all those labels for a test. Now, the most important thing we spoke about right at the beginning of the lesson was a lens. And these lenses are glass. And what they do is they bend, or what we call refract light. When refracting means it bends it, and it can actually make it bigger or disperse wider, which makes the image bigger. We then moved on and looked at an electron microscope, which is a microscope that uses electrons instead of light to produce an image. And it comes in two kinds. There's a transmitting one, and there is a scanning electron microscope. Remember, the transmission is through, so the electrons move through it, so we can see inside. The scanning bounces off the outside, so we use that to look on the outside of things. And last but not least, I mentioned the two ways we measure things in microscopes, and that is with micrometers and nanometers. And they are the two units of measurements that we must use. Keep in mind that they do have an unusual unit of measurement, particularly micrometers, because mm is already used, isn't it? It's used for millimeters. So what we have to do is that's sort of like an upside down H and a U at the same time type of thing, and that is what we use to annotate a unit of micrometers. Now, if you like this video, don't forget to give it a thumbs up and make sure you are subscribed. I have many more grade 10 videos coming this year, so keep your eyes peeled. And if you're looking for the calculation video, that is going to follow this video. If you like this video, don't forget to give it a thumbs up, and I will see you all again soon. Bye.